friends, in this lecture we will see how to design a slab using plate element. Okay, and we will see what outputs will come after that. So this is one of the frame model I have made. Okay, so I have already provided the plate and the dimension for beam and columns. See, so we already assigned the properties. So and these are the plates. So what I have done, I have made one full plate and second one I have meshed in two parts. Okay, so how I have done, just delete it. I will again show you how I did it. Okay, so from here go to general and go to property. Okay, you should go to thickness option. Just go to plate element thickness and provide the thickness of slab that you want to provide. But if there is extra load, if the slab was failing, then we could increase the size after analysis. For now, at the initial phase we will go with 125 mm slab, that is 5 inches of slab. That is the minimum requirement that IS code has required us to provide it. Okay, so we will add it and close it. Now what you have to do, select this plate cursor. Okay, just delete this plate. Okay, how I have assigned the plate I will show you here. Add 4 node plates. Go to add 4 node plates. Okay, there were different methods for this, but for now we are following only this one. So select the corners of your slab. Okay, that is this slab is being countered with beam from 4 sides. Okay, go for second one also. Okay, so now plate has been assigned. You can go and check it here. Okay, this is the plate cursor. So we have selected both our plates and now we have to provide the thickness for the plate. So just select this option and select this assign to selected plates. This plate thickness has been assigned. You can check in rendered view. Okay, these are the columns, these are the beams, and these are the slabs. Okay, now we should go for loadings. So we have provided dead and live load for now being. Okay, so this is the pressure, that is the full plate load. How I have added this I will show you. Go to dead load add option. So go to plate load. So if the load was distributed all over the floor, go for pressure on full load. Okay, so it is acting downwards. Select the GY global in y direction and how much. Now you don't have to worry about the self weight of the slab, as I already applied the plate here. So self weight, in self weight is counted. Okay, just we have to assign the self weight to the plate also. Okay, so this is the dead load, that these are the load that was coming after the structural slab. Okay, like flooring or finishing work. Okay, so if you do tiling, that load was going to come in this. Okay, this is the dead load. So pressure on now for wing we are going on pressure on full plate. Okay, uniformly. So add and close. Just delete this. So this is the self weight. You have to assign the self weight to the plate also. Self weight assigned to selected plates. Now the self weight has been included in plate also, and go for pressure and select the both of the plates assigned to selected plates. Okay, these are assigned to the plate also. Now go for live load and provide the plate load here also. Similarly you have to do that. Okay, we have already also gone to the plate load in live load and provided the load. Okay, live. So this was considered, I am considering it a residential building, so that's why I am taking it as -2 kilonewton per meter square. Okay, you can go and check IS code 875 part second. There were different live loads has been included in the list. So what load you have to provide in different building, that was mentioned there. Okay, so now we have provided dead and live load. If you want to make the combination, you can go for auto load combination, Indian general load, generate load, and add and okay. So that was 1.5, 1.2 and 0.9. So this was okay. Now go for analyze, run analyze. Okay, no error, no warning, everything was okay. Go for output file, go for concrete. Okay, so I have analyzed the structure. Now go for, there was no error, so we go for design. Select the concrete that we are designing, the concrete structure. Select our code, that's what we are following. So IS code 456. Okay, so I have already designed, assigned these options. If you want to again do this, then we can do that also. So just select parameters, just drag all the parameters to the left side, and now select the main that you wanted to give in the property. So go for compressive strength, that we have to provide the grade fy main. What was, so what is the steel tensile strength, we have to provide fy secondary, leave the fy secondary, my minimum. Okay, we should go with this option only. Just provide the compressive strength. I am going with M25. Okay, add. If you don't know why I am providing M25 as 25,000, you can check my earlier classes also. I have talked in detail about these values. Okay, close. Design beams, add. Design columns, add. And design slab element, add. Take off. Okay, so the take off option is help you to calculate how much amount of concrete and reinforcement is going to come in your structure. So that was not too accurate, but they will give you a minimum idea that this much amount of steel will going to come. Okay, so this is F25, so compressive strength. So go with the whole structure. Okay, so I have to use M25 grade in all the beam, column and slab. Okay, F5 main, follow the same to the this one also. Design beam, now it is design beam, so you have to select the beam only. Select set, assign to selected. So design column, select by inverse beam. Okay, oh, shit. assign assign. Now we have to design the element. So go to plate cursor, select the plate and design element, assign to selected assign. Okay, now we go for analyze, run analyze and save it. See what result stats show. We have to also understand that. Okay, so now it is design, concrete design. We'll go for in slab element, what result is shown. These are showing for beam and columns. Okay, you should go at last. So two plates have been generated, two slabs. This is one and this is second. You can just click shift and P, then plate element name will be arrived here. Okay, appeared. See, 65 and 66. Okay, so these are the two slabs that have been generated, 65 and 66. So these are the result. This is provided as longitudinal reinforcement. Okay, so that was area of steel provided in per meter length. Okay, so these are the moment that was generated. Okay, for transverse reinforcement. So what is longitudinal and transverse reinforcement? What Staad show about longitudinal and transverse reinforcement? So I have already downloaded these files, so it can help you more easily to understand what is happening in Staad and what is transverse and longitudinal reinforcement in slab in Staad. Okay, see here what a software did. It only designed for mx and my value, that moment in x direction and moment in y direction. It doesn't design for shear force in x, shear force in y, or shear force in xy direction, or moment in xy direction. Okay, so they are only designing for moment in x and moment in y. Okay, also design is not performed at any point on the surface of the element. A typical example element design show output file. These are one of the examples that was showing. So the requirement required to resist mx moment is denoted as longitudinal reinforcement. So this is the longitudinal reinforcement, okay? In the direction of x, and in fy direction, that is the transverse reinforcement. Here it is showing also. See, okay. And the see it was written also, and the reinforcement required to resist my moment in is denoted as transverse reinforcement. So this value only you have to provide that fy main, fc and clear. They will only calculate for mx and my. Okay, the option is coming. So they are only providing for curtail bars. Okay, for two layers. Okay, they are showing this area for two layers. How? Let's go and check the top and bottom. Okay, so we have to provide longitudinal and transverse reinforcement in bottom also, and again for longitudinal and transverse reinforcement in top also. So we have to provide in two layers. Or okay, so these steel area will be used by you in design of slab or providing reinforcement in slab. Okay, but and what will happen to see here, if you go to post processing, okay, then we go for plate, you can check the slab also, or the maximum stress also here from here. Okay, maximum absolute pressure, or we go for, if we go for different words, so we are going for combination here. You can check the maximum absolute pressure from here also. See, 0.738 is the maximum. Okay, so at every place 0.738 is coming. Okay, and if you do want to do meshing, then what it will does, I will show you that also. Okay, just wait, I have to mesh this. Let cursor, select this option, generate surface meshing. Just click this corner. Okay, and okay, just wait. What happened, it is divided in two parts. See, because I have already earlier meshed these things, that's why it is divided. See, in meshing this will happen. If you divided in 10 equal parts, then your beam is also being meshed in 10 equal parts, so that result was not too accurate for your structure. Okay, I will show you that. Okay, just if you want to only get the area of steel or how much, so you will go for direct and do not do meshing. Okay, if there is a long, tall or high structure where you want to provide a different flow, live load or concentric load in different area, then you can do the meshing. Okay, so that it will be divided in two parts if you want to provide, because it is only creates from center. If maximum load is coming here, then software does not detect that in normal values. But if it will does, if you create meshing, okay, just just first let me merge these files. Okay, I merge these files. Beam has been merged. Now go for meshing. I'm going for meshing quadrilateral. So go for, so he is asking for division. Okay, I will go for 5. Okay, so if you want to go for only 2 parts, then you can go for 2 parts. Why I am going, just I want to show you that beam has been also messy, so that was not correct for proper load distribution. Okay, see, analyze, run, analyze, save. Done. Okay, applied sulfate, so I have to apply the sulfate again here in this. That's why this error was showing, warning was showing us. And that load, as it was distributed in different parts, so this was happening. Just go and, okay, let's don't apply any notes. Okay. Okay, we will go, we'll select it, go to plate. Okay, it was not selected. Go for plate, and it is selected right now. Assign to selected beam or plate. So at every plate it is selected. Sulfate has been selected, assigned to every plate. And now you can assign the property also. I will assign the property. Okay, it is already assigned. See, okay. So that was okay. Now go for analyze, analyze, save. Okay, and warning, everything is removed. View output file. We will go for output. See now, so slab has been distributed in different parts. Okay, see, this was 65, so 65 is coming for at 126 mm square, 126 mm square for coming for whole slab. Right, now it is distributed in different parts. 69, 69. Okay, 126, 120. So every steel was coming equal, but some where load has been more or at center, there will be a maximum value will be changes. See, if you see here, if you see at corner, see 126, 126, the number value is coming, but if you go nearby center value, see where the maximum is calculated, 88. Okay, go for 88. See, 210 and 126 value is coming. Are you getting my point? Okay, so value has been increased here, and this will be more accurate. Okay, so you, so the thickness will be or steel will be increased, so more strength will be provided to slab. Okay, so nearby center value has been increased, and here only 126, so value will be distributed to whole parts. Okay, so more steel will be or accurate steel will be provided over there, but it was so much confusing that nobody designed the slab from Staad. That's why. Okay, just for normal value they assign the plate, and they just check for these values as what minimum value was coming for steel in x and y direction. So these are coming in 2 layers also. Okay, generally we provide the uh, bent up bars in India. So to provide the bent up bar, you have seen that if you provide a curtain bar, we should go for 2 layers. And if you don't want to go for 2 layers, then you should provide the bent up bars. So you can use these values if you're going for curtail bars. Okay, just close it. I think you got how to design it, and one of the option is also there. Okay, so we from here If you want to design it differently, then go for parametric. Another method, it is also another method. Okay, go for create parametric model. So what here you could add just mesh, whatever you want to change the name, you can do it. So go for okay. Okay, so do the meshing at for what you are doing. Just select that area, standard, go for standard coordinator, divide in, so these are coming in inch, that was okay, and go for going for one only boundary edges. Do you want to add opening? No. Okay, so these are also meshed. Now merge mesh, if you do merge mesh, then it is also meshed in different parts. See, you can go analyze, and this is also one of the method. So from which method you like, you can do. This error was coming because I haven't applied the property to this surface, that's why it was coming. Go select the this whole, okay, and assign to selected plates. Okay, just run and save it. Maybe sulfate I have to also assign. See, error was gone, only warning is coming, so we can go and check the warning also. See, sulfate is, so we can go and assign the sulfate, and this value that was coming, so it will also be divided into different results. See this value I'm talking about, so more parts will be distributed, and you can check there. You can go and check in post processing also. Okay, the maximum absolute pressure, what is the maximum, what is the minimum absolute pressure that was coming through this. Okay, so this will see, so 1.87 Newton per mm square is the maximum pressure that was coming on slab, and the minimum was 0.167. Okay, so these are coming, so these are coming nearby here, that's why steel is being provided more here, as I already told you, nearby center here. Okay, so how much part you have divided, this value is going to decrease. Okay, so these are one of the method, or in next lecture I will show you how to design with the help of rcdc. Okay, this is the one of the simplest method to design the beam or slab or column in rcdc using Staad Pro. Okay, so next lecture we will show that. Okay, bye, take care.